Here we go with lesson 1.6.3, inequalities and their graphs. Now, a few notes about how to watch this video and take notes from it. It'd be best to watch the example or listen to me read this. I'll show you some fill in the blanks here, but let it play all the way through instead of trying to keep up and write at the same time. Pause it at the end of this frame and then go ahead and fill in these blanks, okay? Same with the examples. Let them work through the example and then pause it and go ahead and copy the example, the work from the example. I hope you got that. Alrighty, so let's see. We got this one, inequalities in their graphs. Now that you have learned about equations, one-step, two-step, multi-step, variables on both sides, you will learn about inequalities. As you have seen, in any equation, the left side is equal to the right side. On the contrary, the word inequality means not equal to. So there's a fill in blank for you later. Like equations, a solution to an inequality is a number that makes the inequality true. We substitute it in and check it. However, unlike equations, which normally have a finite number of solutions, finite means there's just so many. We saw equations that just all the equations had one solution or no solutions. We did see a few with infinite solutions, those identity ones. But most of them were finite, just so many solutions, one most of the time. Inequalities usually have an infinite number of solutions. One way to identify solutions to an inequality is by evaluating possible answers, and we'll see how to do that in a second. So pause it, make sure you fill in these blanks, and then go on to the rest. Oops, I can go on. Example 1. Let's see. Remember that this symbol means is less than. The left side is less than the right side, if it's true. And this symbol right here means is greater than. This symbol on the bottom left here has a little equal part to it, so that one is less than or equal to. And this last one over here has the equal also, so is greater than or equal to. So we'll see some examples of these. Our first example, determine if the following values are solutions to the inequality. So they give us the inequality r has to be greater than 13. And they want to know if this 20 is a solution, which means I plug it in for r and see if it's true. So if I put it in place for r, replace the r with the 20, we have 20 is greater than 13. Well, that's true. 20 is greater than 13. That means that 20 is a solution to the inequality. So you'll be copying this later. You can pause it in a minute. Check to see if 13 is a solution. So we put 13 in place of r there. It says 13 is greater than 13. No, 13 is not greater than 13. So 13 is not a solution. It doesn't make it true. Let me know if you have any questions. Okay, so you can pause it there if you haven't gotten all that copied down. I want everything copied there. The next example. What do we have here? The inequality says 19 is less than or equal to 3 plus 2p. So they want us to try and see if negative 6 is a solution. So we're going to plug that into p. Substitute it in place of p. It would look like this now. 19 is less than or equal to 3 plus 2. 2p means 2 times that p. You could put this side into your calculator, and you will see they do a few steps here. They did the multiplication first. But if you put it all at once, you should get negative 9 over here. So now this says 19 is less than or equal to negative 9. No, 19 is not a solution. Is not less than or equal to negative 9. So negative 6, what we started with, is not a solution to the inequality. 100, we substituted in there in place of p, and they do the multiplication here first. 2 times 100, 200, and then 200 plus 3. You can put it all into your calculator at once. Now it says 19 is less than or equal to 203. That's true. So this number, 100, is a solution to that inequality. So just testing to see if given numbers are solutions to the inequality. You can pause it and make sure you copy everything in there. Next, you will do the try-its on your own. I'll probably come by and check some of your answers on that. Okay, so pause the video and do the next try-its from the notes. I would come by and check answers in a little while. Alright, so there's some try-its, some more try-its you're going to try, and then now I'm going to the next example. Make sure you do those try-its first. We've got, because inequalities have so many solutions, it is often easier to visualize the answer by graphing them. So we're going to learn how to graph them. The value that equals the variable is called the boundary point. We'll see that in a minute. This number is the boundary between numbers that are solutions to the inequality and numbers that are not solutions. If the boundary point is not a solution to the inequality, we use an open circle to graph it. You'll see that in a minute. If the boundary point is a solution to the inequality, we use a closed or a solid circle. We color it in to graph it. You'll see that in a minute. You'll also notice, I'll tell you now, that when it's not a solution means we don't have the equal sign in the inequality. It's either just less than or greater than. When the boundary point is a solution to the inequality, when we're using this solid circle, is when it does have the equals in it. You have less than or equal to, or greater than or equal to. The equals makes you color it in. When it's missing, we don't color it in. We're missing the colored in. You'll see that in a minute. So here's the first example. Shoot. We'll just show it to you. It says graph J is greater than -7. This inequality is already solved. You know, J is all by itself, just like equations. You get it all by itself. It's ready to graph. The solutions are greater than the critical value, -7, so we use an open circle and shade to the right, it says. Well, let's look at how it's really done. The first step is to put a circle at the boundary point, and the boundary point is what looks like the solution. You know, it's not really in this case, but when it's solved like this, you look at this number right here. It's the boundary point, so we put it there. Now, you should put up what's called a reference point on each side of it. They only do this one side, the one side they graph. You know, when on the number line, we're graphing on a number line here. Here's our boundary point. I like putting it in the middle. And then the number line gets bigger this way, so you need to put a number that's bigger than -7 to the right. And then I like putting one to the left here, another number, okay? And it gets smaller this way, so you need to put some number that's smaller than -7. All right, so maybe -10's over here. So I like one to the right and one to the left of the boundary point. So we put our circle here at the boundary point. Then we look at the inequality. Does it have the equals? No, so it's not colored in. And then we have to decide which way it goes. One way is to take a test point or this reference point and put it into the inequality. All right, if I put 0 there in place of J, is 0 greater than -7? Yes, it is. 0 is bigger than any negative number. So we know all these numbers going to the right here are solutions. You could take any number here will be bigger than -7. That's the way the number line works. If you go to the right, it gets bigger. If you go to the left, it gets smaller. Another way you'll see, when the inequality is written with the variable on the left side, This arrow shows you which way to go, greater than, that way. It doesn't work when it's flipped around, okay? The variable has to be on the left side. You can always take a test point, though. I can see that when I put in -10, -10 greater than -7, no, that's actually, the bigger the negative, the smaller it is. That's false. That's why it doesn't go to the left. Any point over here would make it false. So here's our graph. An open circle because there's no equals in there. Our boundary point when it's solved is that number over here on the other side. And then either test or realize which way it goes. The next one, graph C is less than or equal to 8.5. So again, it's solved. C is by itself on either side of the inequality. And we can see this number here represents the boundary point. So our boundary point this time is 8.5. They put a reference point to the left. What? It's getting smaller. So yes, 0 is to the left of 8.5. Let's put one to the right. I always want 2 in your graphs, okay? In these examples they didn't. I should have corrected them. So something bigger than anything bigger, you know. It could be 9, 10, 11, 12. I'll put 12 here. Just to show that, yes, we're getting bigger this way, we're getting smaller to the left, always on the number line. You have to be careful with negatives. So the first thing we do is put that boundary point there. It comes from the inequality solution right there. Put the circle there. It's colored in because we have the equals in there. And that is a solution, you know, check it. 8.5 is less than or equal to 8.5? Yes. It's not less than, but it's equal to. It's only got to be one or the other, either less than or equal to. So that is true. That's why it's colored in, because it is a solution. Then what? We want all the numbers that are less than 8.5. That's going to the left. Okay, you could even try your test point if you're not sure. Put 0 in for C. Is 0 less than or equal to 8.5? Yes, it's less than 8.5. Again, the one key is when the variable is written on the left side, it's not flipped over here on the right side. We'll show you how to flip them around. This arrow in the inequality shows you which way to go, too, to the left. All right, pause this and put in the drawings and whatever notes you need there with this one. And I'll go to the next one. Now you're going to do the try-its. You're going to try and do those on your own. If you need any help, let me know. Make sure you put in 3 points. We've got our boundary point and a reference point to the left and a reference point to the right. Remember, it gets bigger than the boundary point going to the right. You get smaller going to the left. Good luck. Uh-oh, I'm out here. Now we look at our last example. When given the graph, you write the inequality for it. So let's look at these. So here's the graph. I can see the first step we want to do is pick a variable. Sometimes in problems they'll have a variable on the number line. They'll put it over here somewhere, x or a or n. This one did not have it, so we can pick any variable we want. I chose what here? I chose A. So there, I'm writing it on the left side of the inequality. Here's going to be my inequality here. What goes on this right side of the inequality? Well, the boundary point. So you pick your variable. Now write the boundary value is right there where the circle is, -9. Now we're going to write the inequality. These numbers, what I can tell from here, gets bigger going to the right, are greater than this -9. So all the numbers A are greater than. Now you decide about is the equals in there. Yes, it's colored in, so greater than or equal to -9. It's that simple. Okay. Again, when you write the letter on this side, the inequality should go the same way your graph is going. You can always test it, put in a test value. You got a reference point over here is 0. Yes, 0 is greater than any negative number. It's greater than -9. So again, here it says use the greater than or equal to because we want the numbers to be bigger than -9. Well, how did they know that? Because it's going to the right on the number line. They're getting bigger. And the solid circle, which means including -9, which means that it was colored in. So we got to add the equals. What's next here? The B example. Again, pause it on that last one. If you need the notes, you can always rewind. So this one, all right, same steps. We pick a variable. What did I choose this time? X. Back to my boring X. Then we write the boundary point down. We can see it's at 78. There's what's in the middle of the solutions. And the point that aren't solutions, it divides them into solutions and non-solutions on the number line. So there's our 78. And what? I can see these are numbers, these X numbers. All these solutions are less than 78 because it's going to the left. It is not colored in, so I don't put the equal sign. Again, that explanation. Use the less than because we want numbers that are smaller than 78. And because you've got to put your X on this side too, okay, to follow along. And has an open circle, which means not including 78. Open circle, it can't be equal to 78. 78 is not a solution, just the numbers less than it. All right, you're going to try some try-its now, I believe. I'll come by and take a look at those answers. And now we go to a word problem. We just did a big test on word problems. Inequalities are even tougher than equations because you got to decide whether keywords mean less than or equal to, greater than or equal to. But our first step is still the define. Okay, define a variable, then write an inequality for the situation. We're not actually going to solve them right now. We're just going to write them. The next lesson we solve inequalities. All right, so it says Candace is buying snacks for her book club meeting. She has $15 to spend and must buy snacks for 8 people. How much can she spend on each snack? There's our question. How much can she spend on each snack? So we're going to define the variable. Let P equal the price for each snack. For one snack. Okay. Now we relate here. We're going to look at some words. Let's see. I know I'm going to buy some snacks. I got $15 to spend. She can't spend any more than this. So what I spend has to be less than or equal to $15. Well, what am I spending? I'm buying 8 snacks. How much? So I got to take 8 times how much each snack is, right? So the snacks for 8 people, 8 times the price of each snack, can cost no more than $15. Less than or equal to. No more means less than or equal to. Snacks for 8 people again, 8 times the price of one snack, times the price of each snack, less than or equal to 15 or $15. So that's our inequality. 8 times P has to be 8 times 8 people times the price of each snack, less than or equal to 15. Well, we're not going to solve that now. Next lesson we'll solve. Just how to write it. You do have to do the define and the write. If you can put it in words, that might help you. But I need to see these two. What do we got next? We got to try it. So you're going to try that one. I'll check and see what you got in a little while. I believe that ends the lesson part. So you make sure you do all try-its before you go to the practice, and then you're going to go to the practice and turn that in to me. Good luck.